Hi guys, welcome you all to my channel Explore Edu 2T.
So today we will be learning the next topic in digital electronics called as the analog to digital converters, that is ADCs, or YouTube video lectures on digital to analog converters, that is DAC, consisting of weighted resistor as well as R2R ladder resistor type is been already uploaded on my YouTube channel Digital Electronics playlist. Please go and watch it from there if you haven't watched them. So this class will be talking about ADCs and we'll be giving an introduction of what is ADC, and we'll be talking about flash type of ADCs. Also there is some other kind of ADC such as successive approximation kind of ADC, counter type of ADC, which we'll be learning in the next class. But today we'll be talking about the introduction to ADCs and the flash type of ADCs. So when I talk about analog to digital converters, they are called as ADCs, which convert your analog input into your digital output. There are different kind of ADCs, the flash type of ADC, the successive approximation kind of ADC, the counter type of ADC, and many other kinds of ADCs. But in our video lectures, we'll be talking about these three kind of ADCs. If you're interested to learn other kind of ADCs also, please let me know in the comment section. I'll try to bring up a video lecture on that as well. So let's begin up with the first kind of ADC that we'll be covering in this particular video lecture, that is the flash kind of ADC. Now, what do you understand by a flash type of ADC? If you look at the circuit diagram, we have a voltage divider kind of network, wherein we have a resistor, another resistor, another resistor, and another resistor. We have these op-amps which are connected in the form of a comparator. The outputs are connected to a latch circuit. Then we have an encoder which is going to encode my analog input into my digital output. So basically it's going to convert my analog input into a 2-bit output in this particular case. So how is it going to work? Why is it called a flash type of ADC? What are the advantages and disadvantages we are going to cover? So please watch the video till the end. If you like this video, do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram as well. The links are given down in the description box. Regular updates of all my videos, formula sheets which are going to be really helpful for you in your examination are uploaded on my Instagram page regularly. The links are given down in the description box. If you like it, do not forget me to follow me on Instagram as well. So let's begin up with a flash kind of ADC. So if I talk about a flash kind of ADC, we'll be talking about the input voltage. Now if you see over here, the input voltage is applied to the positive terminal of the op-amp, and the negative terminal of the op-amp is connected to a reference voltage. So if I talk about the op-amp, the input is connected to the positive terminal of the op-amp and the negative terminal is connected to the resistor kind of circuit. So whenever my input becomes greater than my value at the negative terminal, then my comparator output goes high. So for example, if this particular input becomes higher than half, then my X0 becomes 1. If my positive terminal voltage value is lower than the node voltage over here, which is at the negative terminal of the op-amp, my output goes low. So let's try to understand different kind of conditions that exist. So when my input, that is my V in, is between 0 to half, it is greater than 0 and smaller than half, what happens is that my X2, X1, X0 becomes 0, 0, 0, and my B1, B0 becomes also 0 and 0. Similarly, when my V in is greater than half but smaller than 3 by 2, that is, it is greater than this particular node voltage but smaller than this particular node voltage. So what happens? This output goes high, X0. However, my X1 and X2 remains low and I get the output as 0 and 1. When my next input is greater than 3 by 2 over here but is smaller than 5 by 2, of course my X0 is high, but my X1 also goes high because my input is greater than 3 by 2 but smaller than 5 by 2. Hence I have my x1 x0 as 1 but my x2 as 0. Similarly, if my V input becomes greater than 5 by 2, that is, it's greater than all this node voltage, therefore all my comparators goes high, because if the input voltage is greater than 5 by 2, it's definitely going to be greater than 3 by 2 and 1 by 2 as well. Hence my x2, x1, x0 all become 1 and your output has 1 and 1. So these are the different conditions in which my output will be dealing with respect to the input. Now what are the advantages? If you see, just at the single clock pulse, whatever be the input, my output will be produced. Hence it's a very faster kind of ADC. But what are the disadvantages? If you see, this is a 2-bit output, right? B1, B0, and I required 3 comparators. That means for a n bit, I'll require 2 raised to n minus 1 comparator. Or 2-bit will require 3 comparators. Or 3-bit will require 7 comparators. Hence, higher is the value of n, higher will be the requirement of comparators. It will be a very bulky circuit and a very costly circuit for a higher value of n. Hence, ADC is the fastest kind of ADC, Flash ADC is the fastest kind of ADC, but it is very costly when you talk about at higher end of bit value n. So hope I am very clear. If you like this video, do not forget to like, share, subscribe to my YouTube channel, follow me on Instagram as well. In the next class, we will be talking about successive approximation register ADC, counter type ADC. So please do hit the bell icon of this particular YouTube channel so that you get notified anytime a new video goes live. So thank you so much guys. God bless you.